Okay, the next set of SAT style problems. Okay, these problems are all from a section where calculators are allowed, so we'll keep that nearby. Okay, did change the numbers up a little bit. All right, the first type of question. A car traveled at an average speed of 65 miles per hour for 4 hours. The car consumed fuel at a rate of 25 miles per gallon. How many gallons of fuel were consumed for the whole 4-hour trip? All right, so you guys know that dirty old equation, distance equals rate times time, sometimes called the DIRT equation. So what we can do is we have our rate, 65 miles per hour. We have our time, 4 hours. Let's quickly calculate the entire distance of the trip. 65 miles per hour times 4 hours. Hours in the denominator and hours in the numerator cancel out, so we're looking at just MI is miles. Sorry guys, not meters, miles. Miles and, oh wait, I get to use a calculator here. I know it's 260, but just to feel good about that. Oh yeah. Oops. Sorry. Chucked my calculator at my dock cam. So 260 miles is the entire trip, and then if the car gets 25 miles per gallon, we can figure out this by taking our total miles, divide by the miles per gallon. And in terms of units, when we multiply the numerator by the reciprocal of the denominator, miles will cancel out, and this will end up in gallons. And ten point four gallons. So once again, the idea, we can figure out the total miles by multiplying the rate times the time. And then once we know the total distance, we can divide by the miles per gallon to get gallons. Okay, this next problem. In quadrilateral ABCD, AD is parallel to BC and AB is congruent to CD. If AD and BC are both doubled and the length of BE is reduced by 50%, what would the new area be compared to the original? Well, the trapezoid area formula is on the formula sheet. So area equals H over 2 times B1 plus B2. Okay, but we don't know what these heights are. But what we can do is, if this is our original, we can just change the dimensions like the problem says and then simplify. And we will see what area ends up equaling. All right, so let's carefully read the questions and see how we are going to change our variables H, B1, B2. By the way, the bases B1 and B2, those are the parallel sides. So BC and AD are B1 and B2. The height is BE. All right, so what happens to the height? BE, the height is reduced by 50%. So originally it was H over 2. To take half of H over 2, we can just look at H over 4. Okay, and then what else happened? both AD and BC are doubled. So we're going to look at 2 times B1 and 2 times B2. And now we just simplify this mess. First off, 2 in both of these terms, let's go ahead and factor a 2 out of that. And we can actually, because we have h over 4 times this, we can run out of room. I wish I had more paper. Oh, look, more paper. How convenient. We can take h divided by 4, and when we multiply that by 2, we can think of 2 as 2 over 1, and then this cancels out. The 2 divides out of 4, and we get h over 2 times b1 plus b2 is the new area once we've made those changes. And that was the original area. So the answer is the area stays the same, but I'd like to talk for, how am I doing on time on this video? Oh, I'm only 6 minutes in. All right, I'd like to talk for one quick second on conceptually why this is true. Area is always the product of 2 perpendicular dimensions. We're adding 2 dimensions that aren't perpendicular, they're parallel, but we then divide by 2. There's an alternate version of the area of a trapezoid formula where it is h times b1 plus b2 over 2. This version of the formula doesn't look as convenient as this one looks, but they are the same thing. This tells more of the story. We're really taking the average of the 2 bases and multiplying it by the height. So when you multiply 2 things by 2 and take the average of them, like this base here, the average is multiplied by 2. So 2 dimensions we're multiplying, 2 perpendicular dimensions, the height and the average of the base. If the average of the base is multiplied by 2 and the height is divided by 2 and multiplied by 2 cancel each other out, and that is why when we change one of the dimensions by 2, the other dimensions by a half, they cancel each other out. I tried to fool you for sure by saying that 2 things are being doubled, but those 2 things are parallel. So that 2 factors out of that expression and then gets multiplied by the 50% or half of, and times 2 and divided by 2 cancel out. All right, last problem, and then we'll call it a video. Company is selling liquid bottles, I think it was soda in the problem, filled from a 1,000-gallon tank. How many 20-ounce bottles can be filled from the tank? And then there's a little unit conversion hint that there are 128 ounces in 1 gallon. So what I think we should start off with by doing is, let's figure out 1,000 gallons. How many ounces does that equal? And of course, we can do that by multiplying by the scale factor. I have gallon in the numerator, so I want gallon in the denominator to cancel out, and then 128 ounces in the numerator. Gallons cancel out. My units are now ounces, and 1,000 times 128. So that's how many ounces are in a 1,000. Let me write that a little bigger. That's how many ounces are in a, not ounces, ounces. I just totally forgot. Oh my God, that was the U of ounce. I mistook one of my zeros for an O. I'm so silly. All right, I'm glad I recopied that. That was just too sloppy there a second ago. So we have 128,000 ounces in a 1,000-gallon tank. And if each bottle is a 20-ounce bottle, we can just divide this by 20. Ounces cancel. 10 divides out. It looks like we're just looking at half of 12,800 or 6,400, and that would be bottles. I didn't put units there, but if I did, that would be it. So unit conversions, if we know how much is all together and we're asking how many 20-ounce bottles, we'll take the whole number of ounces, divide by 20. That's going to give us the number of bottles. And yeah, there are some more SAT problems. And this video is just over 10 minutes, and it's just before 3 o'clock. Hopefully this all gets uploaded to YouTube in the next 5 minutes. All right, peace out.